Hey guys, welcome to the last video of the audio classification series. In this video, we're going to actually make predictions on audio files using our machine learning model that we trained, okay? So there's a lot of things to write here. Nothing is actually new. Everything should look really similar to you, but there's going to be a lot of like file manipulation happening, and if you don't know pandas very well, then it'd be a little confusing. But let's start by just creating we're just going to have one function called build predictions, and we're going to pass it a audio directory. And so basically we're just going to say, hey, look in this directory and make predictions on all the audio files within this directory. Another thing, make sure, just to update everyone, after you run your model.py file from before, you should now have a conf.model and a time.model in the models directory. And in the pickles, you should have conf.pickle, time.pickle. Okay. And we're going to be making this new file called predict.py. So go ahead, pause the video, and make sure that you have all these import statements. You should be good to go. So build predictions is going to return three things. It's going to be y_true, which is going to be the true class. I'm going to be making predictions on all of the training data that we already trained on, but obviously we wouldn't normally have the true labels. But I want to show you guys how to create an accuracy metric if you wanted to do something like that. So we'll also build yPredict, which will be all the predictions from the neural network. And really quickly, the output of a softmax layer from our model is going to be a 1×10 array. If you were to add up all of these values, they would total to 1. Okay, so the idea behind softmax is it's kind of like extending the it's like an extension of logistic regression, or using the sigmoid activation to create individual class probabilities. So if I wanted to know the probability that a file has been classified as acoustic guitar, I would just look at the 0th index of this 1×10 array, and I would get its probability. All right, and so that's what we also are going to be building out. It's going to be called file name prob. It's just going to be a dictionary. Okay, and before we start building this out, we're going to grab some variables that we're going to need to actually run this function. So we're going to import instruments.csv. And obviously you're going to have to change some of the stuff's going to be missing if you are just running on audio files and you don't know their true classes. You can just remove that stuff from here. But just to give a working example, I'm doing it like this. So now we're going to create classes, which is going to be equal to numpy unique of dataframe.label. And then I'm going to create a dictionary called file name to classes, or I guess file name to class. And that will equal the dict of the zip of dataframe.fname and dataframe.label. So for every file name, I can immediately get its true class, its label. And at this point, we can create the pickle path. So we're going to do os.path.join of pickles, and we're going to join. At this point, you're going to say, you're going to define which file or which model do I want to run. All right. And so the reason of creating a pickle path is we actually want to figure out what was the configuration for that specific model. So we're going to say with open of ppath, we're going to read bytes as handle, and then say config. So we want to grab that config class that we stored as a binary file, a pickle, and we're going to do pickle.load handle. So now that's all going to store in config. At this point, now that we've grabbed config, the reason why we do that is we want the min and the max, so we know how to scale our data before we run prediction on it. Okay, so now we're going to say model equals load model of config.model path, and that will load our model from Keras. And at this point we can actually just grab, like I said, we're going to be build predictions is going to return y true, y predict, and file name probability. Okay. And so now we'll actually just call build predictions, and our audio directory is going to be clean because those are our cleaned audio files that we want to make prediction on, right? So now we want to actually let's build our function now, right? Unfortunately, we have to, it's not as simple as just like calling it. We're going to need to step through each audio file, but instead of randomly going through them, we're going to go through them very precisely in a straight one shot instead of like randomly sampling like we did before. So this should look really familiar. So I'm going to say extracting features from audio, make a quick print statement, and I'm going to say for file name in tqdm of os.list directory. And the way I'm doing it with, like, I could iterate through the data frame file names, but in reality you would just do an os.list directory of our audio directory. And now I'm going to say rate and wave is equal to wave file dot, we want to read that, and we're going to read os.path.join of our audio directory with our file name. So we're just reading on our file, and then in order to calculate the accuracy metric, I'm going to say label is equal to file name to class of file name, and C is equal to classes.index of label. So I'm going to grab based on, actually, let me just run, I wonder, let me see, I can probably leave the function like this. Oh, it might yell at me if I run that. Let me see if I can run this really quickly and just explain this a little bit better. So it takes a while to import the model, but yeah, once we have classes, so classes is just a list with index of 0 to 9 of all of our individual classes, right? And so when I come in here and I say, hey, I want classes, but I want the index of that label, we're just pulling out the classes that match with this. Okay, so y probability is going to be equal to a list. And now we're going to go through each specific index, and we're going to walk through all of the audio files. So for I in range of 0, we're going to say wave dot shape of 0. So we're going to go the whole length of the file, but then we're going to subtract config.step. And again, this is why we store everything in the config file. We can go forward via config.step. So we're going to pass over the entire wave file and get these indexes. So we're going to say sample equals wave from I to I plus config.step. That looks good. Now we're going to create this little tiny, it's going to be a 1 by, it's just one sample. Like when we originally built it out, it was like 20,000. This is just going to be one little 1/10 of a second of audio. Okay. So what we're going to do is we're going to call mfcc, and actually I'm just going to copy and paste this to make this a little bit faster. Should have something that looks like this. So these are all the same settings that we used before, right? We're just calling it on sample. And now we just need to scale that data. So we say x is equal to, in NumPy, we have to now scale between our min and max. So we're going to do config.min divided by config.max minus config.min. So that's the range, right? Did I do that right? Yep. And now, let's see. Because I created modes here, I'm going to say if config.mode equals convolution, then x equals x dot reshape of 1 by, so again we need to reshape our array to be a 1 by the first feature, the second feature size, and because this is the convolutional model, we need the single grayscale channel for our array. And else if config.mode equals time, then we want to say x is equal to, and there's a faster way to do this. If you ever want to reshape an array and just add like a single dimension onto something, you can use numpy.expanddims, and you can expand the dimensions for like some array x and say I want to expand that in the 0th axis. So what you're doing is you're creating this 1. So you're just expanding to 1 sample, which is what you already have, okay? Now let's say y hat is equal to model.predict. So now we're going to use our sample that we built. Actually, do I have a syntax error here? Equals, yeah. So now y hat, which is going to be our prediction that we're going to make, we're just going to feed our one sample to model.predict, and we can also create y probability. So the actual output y hat is that 1 by 10 array that I was talking about earlier, and we will append y hat onto y prob because that's what it is, and then y predict is going to be, we're going to append numpy.argmax of y hat. So we are literally going to get the maximum. So for the maximum value in y hat, I want to get the index of which that occurs. So that's just going to be a number. And then we can say y true. Hold up, my dog wants to leave the room. I'll get back to this. All right, guys. Had to open up the door to let the dog out of the room, but we're back at it. Let's do y true dot append. Now, okay, so the true classification is going to come from this class that we stored earlier when we looked up the index from classes based on the label. And then, so at this point, we've gone through each file name, and we want to say file name prob of file name. So we're going to build out this dictionary. So for each file name, I want to store the associated probability of the classification of that file. And I'm going to say like that's just equal to numpy.mean. So I'm going to take the result, the mean of every single thing in the y prob list, which I created right here, right? So I created a list, I stored all the predictions in it, and then I'm going to take the mean of them over axis 0. And we have to call dot flatten just to flatten out this array. That's just what you have to do. If you actually looked at the output of numpy.mean, then you'd see that you have to flatten that array before you do anything with it. So now we're going to return y true and y predict, and we'll also return file name probability. All right. So now let's go down here and uncomment build predictions, and let's build the accuracy score. So accuracy score is going to be equal to, this is actually from, I think it's from scikit-learn.metrics. Yep. So the way this works is you will pass it y true, which we already just calculated, y predict, which is going to be equal to y predict. That's good. And we're also going to create y probabilities. So y probability is just going to be a list. So what I want to do here, I'm going to modify the data frame that I've already imported, like right here. And I'm going to fill up this data frame with the associated class probabilities. So each column will be the class, like acoustic guitar, and it will give the probability from all of our aggregated results every 10th of a second and store that probability in this data frame. But the way to do that, you'll see. hopefully, if you can understand this. So for I in row, and I'm going to use something called dataframe.iterRows, and I'm going to say like y probability is equal to file name prob of row dot f name. So when you do iterRows, it'll have an index, and then I'll have everything that is in the row, and you can just say row dot series, which is file name, to get well, actually, okay, so we're indexing this dictionary file name probability. So for any file name, I can grab its probability, and then I'm going to say y probs. So all of the probabilities is just going to be accumulating this individual output. And then I'm going to say for C and P in the zip of my classes and y probability. So y probability is a 1 by 10. Classes is just 10, so you can zip them together. And what I'm going to do is dataframe.at. So this is an in-place operation where the data frame at some arbitrary index of 0, and for some new label, which will be called class, I can literally just insert the value into there. So I'm going to say dataframe.at IC is equal to P. So the P is just the associated probability for that class. Okay. And you'll see what I mean like when we actually run this. And now I'm going to say yPredict is equal to classes of numpy.argmax of y, and I'm going to say for y in y probs. That's good. Okay, so this is a list comprehension. Oh, whoops. I was like, that looks really weird. You need to take that brace and just move it there. So this is a list comprehension where we go through all of our y probabilities, and then we get the associated label where classes is like maximum. So the maximum classification from y, just grab the class for that so you can create the y prediction. And now we're going to say dataframe.yPredict is equal to yPredict. So now we're just creating a new column called yPredict in our data frame, or I guess our data frame, and then it gets saved as a CSV file. So if you want to output a CSV file from a data frame, you just do dataframe.toCSV of predictions.csv, and really weird, but you have to say index equals false so it doesn't automatically bump the index into a column. And let me see if that runs. Config has no attribute stop. Yep, that would probably, it doesn't, so that's a typo on my end. Let me make sure this actually runs. Okay, so it looks like it's extracting all the features. I have another, like some people wanted to know how to do live audio prediction. I did do that in a separate repository. I don't think I'm going to make a video series on it because it would take forever, and I don't like building user interfaces in Python. They're really ugly and clunky. So if you guys want, I'll like pin that repository if you want to see it. But this is actually running fast enough to do live classification, but I think I was able to get like 30 frames per second when I made that live demo. But unfortunately you have to wait for all of those features to get calculated. So that's what that TQDM was. So now that that ran, let's take a look at what it built. So if you go back to your directory, you should see a predictions.csv file. And let's just go ahead and open this with Excel so you guys can see that. I built it in Excel because sometimes people like things in Excel. And personally, I don't use it, even though I'm a data scientist. I do everything in Python. So originally we had file name and label. And now what we have are these individual columns for every possible class that we can classify as, and we have their individual class probability. So for the whole file of this file name, there's like a 0.01 0.2% chance that it's going to be classified as an acoustic guitar. Okay. But when you go, let's take a look at, so the true label of this was a saxophone, right? And if I go here, you'll see that, yeah, the algorithm thinks that there's like a 95% chance that this is a saxophone. And what I did with the argmax function is I took this entire 1/10 and I grabbed the index from it and I said, okay, well, what's at index 0, what do I have? I have acoustic guitar. So it takes the maximum, which is 0.95 from saxophone, and that's what ypredict is. And actually, I think this is 100% accuracy for every single file, which it should be because we trained it anyway. But it's saying that like 95% of the content in this audio file should be part like a saxophone. And that's what I think is happening. So, and if you went down here, this is only 80% of the file. So 80% of the file, I think like 80% of the audio in this file is a saxophone. Overall, we'd threshold, it's higher than everything else, so we'd threshold it to saxophone. So that's what you get. You get one big CSV file for all 300 audio files, okay? And they're all correct, which is what you would expect out of the convolutional model. I did run the time model through here with the recurrent neural network. Its performance was not quite as high. Like, it actually gets quite a few things wrong, so run that if you want, but hopefully that gives everyone like a really good example of how to do audio classification. If you wanted to, you could serve this up like often, like when you deploy machine learning models, you might serve it up to like a web API, and then all of the results will be like someone could query an API and it could produce actual results. And like if someone was a really good web developer, then they could create like a whole user interface and then run real-time audio classification using this. So but this is just all the background stuff that data scientists and machine learning engineers have to do to deploy that system. Okay, so hopefully that helped you guys, and thanks for watching the series. It was really fun to make. More people are like seeing these videos all the time, so let's just hope that YouTube keeps recommending this so that people can learn stuff with everyone else. Okay, so thanks for watching.